Alright, in this video I want to demonstrate what the equations are going to look like. These equations for circles are going to look like. So in the last video I showed that this is the algebraic equation for a circle given a radius r and a center at hk. So what that's going to generally look like is, I'll just do an example here. 16 is equal to x minus 3 squared plus y minus 1 squared. So I'll just do a quick graph of what that's going to look like. I know if this number here is 16, then the radius is going to be the square root of that. The square root of 16 is 4. So I have a circle with radius 4 and center at 3, 1. So I can count over 3 and up 1 to get the center. And then I know the circle is going to be about that big, and it's going to look something like that. Okay. So what if I change these values? What if I let them be x plus 3 and y plus 1? Well, all that changes is now my center is at negative 3, negative 1. So I'll just do the same thing at negative 3, negative 1. The center is there, and the circle looks like that. Okay. And so however I change these values here, that just translates that circle to another part in the Cartesian coordinate. And this value, we always want to pay attention, is going to be the square of the radius. So the radius is the square root of that number. All right. So another common way we might see circles is we're going to see it in this type of form: x squared plus 4x plus y squared plus 6y minus 3 is equal to 0. So we'll just do this as an example. So in this form, these equations here have been multiplied out to their polynomial form, their expanded polynomial form, rather than in these forms here, which we can see that it's a circle. So we have to complete the square on the x variables and the y variables to put it into that form. So I'll just demonstrate how that's done. It's pretty straightforward. We just do it the same way we completed the square in earlier videos. I divide this 4 by 2 and square it. That's going to be 4. And I'll just put a parentheses around that to know that's the term that we're about to contract into that form. And then we also have to remember I added a 4 here. We'll do the same for the y variables. Y squared plus 6y, and then divide 6 by 2, square it, plus 9 minus 3. And then since I added a 4 and a 9 to this side, I want to add a 4 and a 9 on the other side as well. And then I can condense these into x plus 2 squared plus y plus 3 squared. And then 4 plus 9 is 13, but I'm also going to add 3 to the other side to get rid of that negative 3 on this side, and I'm left with 16. So now we can see this fits in with our algebraic definition of a circle up here. In other words, we have a radius of 4, and we have a center at negative 2, negative 3. All right. So that's one way you might see it, but these values can change. See, if these values here, that 4 and that 6 change, that's going to change. It's going to be a translation, as long as we can. Those changing the values here will represent a translation, and actually a change in the radius as well, depending on if this number is going to change with those numbers in a certain way. So what I mean by that is, let's do this. Let's say, well, what if this is 10x, and then this could be anything. I'll just let it be 4. Keep it kind of simple. So I'll just say minus 7. Okay, I think that gives me a... See, it matters what I choose these numbers to be because it'll change what the radius is. And I want a radius that's a whole number, just to make it easier. Let's see. Okay, so I'm going to complete the square in this equation. So I'm going to have x squared plus 10x. Now I'll need to add 25 here, which is 10 divided by 2 squared. And then y squared plus 4y plus 4. 4 divided by 2 squared minus 7 is equal to, so now I'm going to want to add 25 and 4 to this side of the equation, or 29. And then I'm going to add 7 more, so 36. So I don't know if you can see what I did there, but I set it up so that the radius is 6. And then we're going to condense these into the form we want. X plus 5 squared plus y plus 2 squared. Alright, so this is the form you might see the equation of a circle given in, and then you have to know how to set it up into this form so that you can see where the center and the radius, or see what the center and the radius comes out to be.